and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
The first calendar year since 2010 on which all of February, March, and November began on a Tuesday is 2022. What is the sum of the next 3 calendar years for which this is also the case? Okay, so let's look at February and March first. So for them to both begin on a Tuesday, they have to be 28 days apart. So if it's a leap year, they'd be 29 days apart. And if it's a non-leap year, they'd be 28 days apart. So first we know that these years can't be leap years. And then the number of days between March 1st and November 1st is always 245, which is a multiple of 7. So they both have to start on the same day. So let's just look at, so we know that November 1st in 2022 is a Tuesday. So let's look at what day of the week that'll be on each of the years. 365 is 1 more than a multiple of 7. It's 52 times 7 plus 1. And then if it's a leap year, it'll be plus 2. So it'll shift 2 days. So we got on 2023, it'll shift 1 day. And then 2024, it'll shift 2 days. It'll do 1, 2, 1, 1. It'll keep repeating that over and over again. So let's just look at the total number of days it shifted. So 2023 is 1 day shifted, so Wednesday. 2024 is 1 plus 2, or 3 days shifted, which is Friday. And then 2025 would be 4 days shifted, which is Saturday. And then 2026 would be 5 days shifted, which is a Sunday. So it keeps repeating like this. So every 4 years, it shifts 5 days. So we want the number of shifts to become a multiple of 7, so that it'll still be a Tuesday on that year. So let's look at this column here, the column with the 1. So the next one would be 6, and then 11, and then 16, and then 21, because every 4 years, it shifts 5 days. So 17 years after 2022, we get that 2039 is a Tuesday on each of these months. Okay, so then we look at the other column. So we know that the second column is the column with all the leap years. So okay, the third column, it would be 4 and then 5, and then you add 5 every 4 years. So it would be like 4, and then there's a 9, and then a 14. So that means that, so that's the third row and the third column. So that'd be 11 years. So we found that, okay, so 14 is multiple of 7, and then we continue, and then we find that 35 is also a multiple of 7. And then the second column would be the leap years, so those don't work. So these would be the 3 next ones. So, okay, so we found that, so 11 years after 2022, 17, and then this one would be 4 times 7, which is 28. So, okay, so those are the next 3 years, which it'd be a Tuesday on all 3 of these months. So when we do that, it'd be 2033, 2039, and 2050. And when we add those up, we get 6122. Okay, hopefully that made sense, but just to go over it, basically what we did was we noticed that every year the calendar shifts either 1 or 2 days. And so we're trying to find the years in which it shifts a multiple of 7 days. And it's not a leap year. So we found that after 11 years, 17 years, and 28 years, it would be a Tuesday. And so that we found the 3 years would be 2033, 2039, and 2050. And we add that up and get 6122. kit.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.